Alright, hello everybody, JLX again, coming with another tuning video. So in this video here we're going to be covering step 5, which is our speed density. This is the tuning step that I don't enjoy the most, mainly just because it takes a lot of time, for me at least, just because of how I operate. It takes a lot of logging time, driving, changes, but in any case, let's go ahead and jump into speed density. I'll share with you how I got this set up. So this is pretty similar to our MAF setup. So in this case, what we did, is I will reset for my MAF tuning, reset all that stuff back to a stock condition, and then get ready to do the setup for speed density. And for the most part, it's pretty much the same. The goal is to disable the adaptive fuel controls, so your long-term fuel trims, your O2 sensors, so that way you're running in open loop, turning off the deceleration fuel cutoff. Again, changing the AFR EQ ratios, and like I mentioned in the last video, this how I do it. It might be a lot different than what you might see other folks do, but this is just the way I go. So the main difference really is this guy down here. So which is disabling the mass airflow sensor. And so we're basically forcing the vehicle to rely only on speed density with the map sensor to operate. So this is one of the neat things about GM. Is it's not all just a speed density system and not all just an airflow system. When it comes to MAF, they use both sensors and then kind of interpolate between the two depending on the condition that you're driving in. So in any case, that being the case, we need to account for that. So we're going to go into excuse me, engine diagnostics, and we want to disable the MAF. So hopefully you won't get any check engine lights when you do this. If you do, just a matter of going in there and turn it off, and it becomes annoying, then you can just tell it to ignore it. So once we have that set up, we can get ready to start logging our speed density. So again, what's in play here is going to be using your wideband O2 sensor. You want to log what your command is. But for our data table, and again, I'm not going to go through how these are created. I mean, I can if people want me to do that. Feel free to let me know in the comments. But kind of as I said before, there's already some good resources out there that go into the details of how to set these up, and mine's really no different. Meaning it's these data tables are based off of what's inside VCM editor. So and then just start doing your driving and start logging it. So let's see. Am in speed density? Again, like I mentioned before, it's kind of a two-pass. First I'll do steady state, and then once I have everything dialed in, so my map timing. Excuse me. Then I'll come back and do full throttle. So you can see though that it can take quite a bit of logs to get this dialed in right, but it's not too terribly bad. It's just a process. Now I'm going to show you maybe something that is a little bit different from how folks do when it actually comes to making changes. So let me pull up this guy. So this is the virtual volumetric efficiency table for the stock LED. Not really a stock, it was actually a tuned, but this is what the VVE table looked like before the supercharger. So this was a stock LT4 VVE table that I modified during the tuning process. So I have DoD off of mine, so I'm not going to be worrying about DoD. But what you want to pay attention to is make sure you're on open. Most likely that's the one that your system's going to be using. The closed one, I've read different opinions on what people think that's used for. I think the most common explanation I've heard is for variable length, dynamically variable length intake runners that can be changed dynamically. But in any case, I would trial and error is probably your best way. If you make a change on open and you see that change happen in the logs, then you know you're in the right area. Same with the closed. But for me, open is the one I need to change. And then I don't really concern myself with intake and exhaust angles. So in any case, this is what the table looked like for the L83 factory L83 VVE table with changes I made from when I was tuning before I had the supercharger. Now let me compare that with what it looks like now with after having the supercharger installed. So again, we're going to go to the open, and let's put this on that guy. So hopefully you can see it looks quite different. It's actually pretty interesting. So what I decided to do in this, again, coming back to why not use the resources that are out there, and what I mean by that is utilizing the VVE tables that the GM engineers already put in for the LT4. So I basically used that table for the for my setup, and for the most part, it's worked out really well. If I wanted to have done that, it would have taken a lot more time to get this thing mapped out. Now, let me do this. Let's close this guy out. Let me go over to here, and I want to show you what the actual stock Z06 table looks like, VVE table. So let's go back to, let's see, base configuration changes. We'll grab this 2016. And we'll show you what that looks like. I'll show you what it looked like before I modified it. Alright, so let's go to this table. Let's expand that. Let's go to open. And let's put this into a 3D chart. So that is what I started with. And this, where did... Oops, did I... Okay. Sorry. Confused myself there for a minute. I probably shouldn't have closed it. That's what confused me. Alright, we'll throw this in 3D chart. And this is what I have now. So, you can see this is the stock 06, and this is mine. Again, stock 06 and mine. So you can see it's a lot different than what the L83 looked like. I mean, obviously, right? It's a totally different beast. But I wanted to, since it's kind of a hybrid at this point, the stroke is the same on all these Gen 5 engines. Well, that's an LT3, LT4, LT1, LT6. They got the same stroke. It's just the bore that's different. And so outside of the the camshaft, the bore being different size, it's getting close to looking like what an LT4 is. And obviously some other details, but anyways, so I started off with the stock LT4 base table here, and what's kind of interesting about this is I think these are the actual fuel zones that they have mapped out here. They're a little bit higher than some other areas, and that's really kind of the kicker with speed density is when you start to get crossing fuel zones and making changes. It can really throw the table when you go to calculate the coefficients out of whack. And so there's some videos out there of how to tackle that. What really the direction I took is, I'd go out there and I'd pull some logs for this guy. Maybe we'll just go ahead and pull one up just to show you what it looks like. Let's see, are we in the logs? Yep, we are. Okay, let's, got any insight here? Nope. Okay, let's go back. Oh, these are the pulls, that's why. I don't have any pulls for that. Let's do drives. And see density. And steady state. And I guess let's do this one here. Hopefully this isn't a 15-mile trip. It'll be a pretty big log file to load. We'll see. Okay. So something like this is what I really like. You know, something like this ain't too bad. Okay. There's one thing to that I would like to point out here, and that's what, and I reason why I bring that up is that's what's going on here. This 1600, and I know it because it happened a lot. So don't forget, part of one of the, I guess, side things about disabling the deceleration fuel cutoff is that means that you're still probably going to be spraying some fuel, and that's what you're seeing here. So you can see for the most part, you know, this thing's running not too bad. You know, it's getting pretty close to my target. But what's going on here is when I decelerate. So this, and I know for this for sure, this is the 1600 and 1800 is kind of my normal RPM range when I'm cruising on the highway. You know, whether that's going 55, 60, you know, all the way up to 70, 75. This range is where, you know, the engine just likes to cruise at. So it's where I'm going to get a lot more data points collected. And also, what I'll notice when I'm driving and logging is it might begin looking like this, and then as soon as I let my foot off the throttle, it'll start looking like that. So you're kind of tuning on both sides of the coin with having that the DFCO turned off. So just something to keep in mind when you see stuff like that. Now you could, you know, I think in an ideal situation you'd want to go ahead and try to clean this up as much as you can. You know, not only when you're feeling under a load, but also when you don't have a load on the engine. You want to keep your AFR to close as target as you can. And for me, I try to do that as much as I could, but it just got to the point where it was just getting pretty granular, and I was putting up a lot of effort into that. So I try to get it as best as I could and focus more on just making sure that under engine load, when the engine was under a load, that my AFR was close as target as I could. So anyways, you know, pulling, so what I would do is, and I think what you'll see in a lot of other videos is people just come in here, you know, they'll do the old copy, they'll come back over to the to their editor. Let's do this one. You know, and they'll do their pace special, and maybe they'll do it by percent or multiply percent minus half. And I didn't really take that approach, and I don't really take that approach in this. And the reason why, and this is really where it comes from, is we're scrolling open. Let's go back to the stock one here. You know, GM has put a lot of time and effort into getting these really well, and for the most part they work out really good. You know, for the tunes that they pump out on a mass-produced vehicle, they run really well for all the different environments that seems to be putting in. You know, cold conditions, wet conditions, dry conditions, hot conditions, high humidity, low humidity, high altitude, low altitude. You know, they really put in the resources to get this engine, any of their engines, to, you know, in some models that's a hit or miss, but for their top line models like your trucks and your sports cars, they do a really good job of trying to get this dialed in and running really well in those conditions. And the last thing I want to do is go in here and just destroy all that work. You know, I need to make the changes that I need to make for the changes that I did to the truck, but I also don't want to go and, you know, just make a mess of everything and fight that. So instead of just coming into the speed density, or yeah, the virtual volumetric efficiency table and doing the old copy and paste, I just really focus on the data that I captured. So, for example, if I was gonna, if I'm looking at this file, um, you can see here I went all the way up to 1.24. I would say, all right, so 1,000 RPM, yeah, I got some cleanup I can do there. 800, that's 600, 800, that's kind of low speed, idle, and it's looking pretty good. 0.25 minus 1, that's subtract, taking away some fuel, but that's not too bad. 800 is not too bad. I mean, 1,000, yeah, it's got some rich areas here. But for the most part, I think I'm going to focus probably from 1,200 to 1,800. And so then what I do is I find that area, and this is where it really comes important that you try to get as much samples as you can for data. Here it's pretty focused, just between 600 and 2,000. So, so the results is going to be your effort plus your time. So the more time you put in here, the more effort, the more data samples you collect, the better off it's going to help you with making this a quick and easy process. So going back to what I was talking about, so what I'd say is, okay, between 65, or let's look at 2,000 here. 2,000 RPM, I don't really have a lot of data points here that I can go off of, so I'm going to focus, let's say in this case, I'm just going to focus on 1,200 up to 1,800 RPM. And so what I would do is I'd come over to, I need to find, is this the stock one? Yeah, this is the stock one. So I would say, okay, come back over here, and I'd say, all right, so 1,200 up to 1,800. I'm going to modify these guys. Now, I'm not going to just copy and paste. What I'm going to do is, going back over to my log here, I'm going to say, okay, so 1,800 is not looking too bad. I'm taking some fuel away, but okay, as I start getting up to higher RPMs and bringing in more air, I can see it's getting pretty rich. So I might just lean this out a little bit. Let's say I'm gonna take out 3%, and that's how I'll do it. Is I'll just come back to the table here, and I'll just take out 3% of fuel from this. And then what that does is it makes, when you have to go and calculate your coefficients, it makes it a lot more. The changes aren't so dramatic on it, and you're doing over a wider area and keeping everything kind of keeping those. I guess what I'm trying to say is you're keeping those stock values in play. You're just baby stepping them down or baby stepping them up. You're not doing really large changes, and you're getting a lot of spikes and dips in your table. And I wish I had a 3D chart where I could show you that. Because I guess what I've seen doing this process is you get to a point where there's so much variability in your log here. Going between 5 up to 10, and just doing, whether it's just copy and paste and multiplying by a percent or even multiplying by a percent minus a half. It starts to just really create a lot of spikes and dips. And even when you try to go in there and smooth things out, you're really interpolating. You're not going off of real data. You're just kind of interpolating. So you're just kind of going in a circle. And I'm not saying that's bad. I mean, it does work. I did that a lot before. It's just, I've just found a method that works better for me. Is just targeting areas and just that whole RPM range or whatever it be. Just go up and down in percentages, and not really just taking the raw data and copying and pasting in there, or using the copy and paste percent function. So I found that really helps with me. It really helps with not getting those weird situations where it looks okay, and then you go and hit calculate coefficients, and all of a sudden you get this huge spike that just jumps up here and everything's way back down. Then you got to read it all over again. It really helped me out in those situations. And so what I mean by up and down with the percentages, so the way this works is by multipliers. And And I don't want to school people on math here or anything, and I'm definitely not an expert to go into that type of stuff. But let me just show you what I mean by that. It's probably helpful just to visualize it than just me talking about it. Oh, come on, calculator. Surely can't take that long to load calculator. Alright, so what do I mean by multipliers? So you notice here you don't have any divisions or subtractions. You basically got multiplication and sorry, addition, multiplication, and making things equal. So if I wanted to reduce the 1800, or sorry, the 1200 up to 1800 by 3%, I'm taking away, right? So I'm starting off with 100 parts, and I'm going to take away 3 from it. That's going to give me a leftover of 97. Now if I divide that back by the original 100 parts, it gives me 0.97. So what that means is I'm going to come up here, 0.97, and I'm going to do that from, what did I say, 1200 to 1800. I would multiply that, and it's going to reduce everything that's highlighted here by 3%. And it's the same way going the other direction. So let's say you're in a lean condition and you want to richen it up. Let's see here. So what I do is, again, I'm starting with 100 parts. Let's say I want to add 3%. So simple math, I'm just going to add 3 to it. And then we're going to divide it by the original of 100 parts, 1.03. So if I wanted to add 3% to that range, I would do that. And I think, again, if I was doing the 1200, 1800, so I would multiply that by 1.03, and that's my multiplier. So when we buy a multiplier, that's going to either, in this case, is going to raise everything here highlighted by 3%. And same with 0.97, it's going to reduce everything by 3%. So that's generally the approach I would take. Is I would go grab logs, again going back to what we did with the math, starting off in the neighborhood, some low speed cruising, then getting into town speeds, 35, 40 miles an hour, 45 miles an hour, then getting up into the highway speeds, 55 all the way up to 75 miles an hour. And through each one of those operations conditions, taking logs down, looking at my logs, and just seeing where my data is laying, and saying, okay, maybe in the next, let's say I'm at the highway speeds now, and so now I'm starting to fill up more of the higher RPMs, and I can see that maybe I got data from 2,000 up to 3,200, and then just looking at the data and saying, okay, is there a specific area that's much richer than another area, or a certain area that's much leaner than another area, or are they all pretty rich, or are they all pretty lean, and just attacking it from a holistic perspective versus just grabbing all of these. And the reason why I'm spending so much time on this is because with these values here, this is really going to screw you up. And what I mean by that is, like I said before, watching, so I have the computer in the vehicle, right, where I can't, where I don't have to be distracted, take my eyes off the road too long to see these values. So I'm watching these logs and where my z-axis is hitting, where my cell is hitting. And I can tell you, when I was doing that, these values under load, when I have my throttle applied, were looking really good. It was looking like this. And it just, when I just happened to decelerate, then all of a sudden all those values started to get more into a lean condition. And so I needed to add fuel, which, so it's really the ratio of how much, for the duration of the time you're driving, the ratio of the data you're collecting when you're under load versus when you're not under load. And I hope that makes sense. But that can really screw up your values, because if you were just to copy and paste this, you now have a band here where you're taking fuel away, and then a band here you're taking fuel away, and then a band here you're adding a lot of fuel. And then you're going in there and having to smooth things out and having to interpolate and spending a lot of time around those areas trying to clean them up. So it's just a mess. So just understanding that, for speed density, when you're out there grabbing logs, it's recording while you're not under load, when your throttle is closed, but there still might be some fuel being sprayed in that system, and also when you're under load, so you have a partial throttle open or maybe all the way open, and you got to really just understand what's going on there, those dynamics, and that way you're just not fighting the system. And so I hope that makes sense. I'm not saying this is a better way. I'm not saying it's going to probably work for you, but it's just after doing this for a while, just going with this method has really helped me out with just not focusing and just copying and paste these things with by percent or percent minus a half. Just tactfully going in here and looking at areas that need to be richer and need to be, and it's same for if you just wanted to tackle a small area like this. I would do the same thing. Let's say between again 1200 and 1800 over here at 76 down. I would say, okay, we're over here at 1200, 76, so 1200 to 1800, all the way down. Let's say I needed to clean these up. I would kind of do the same thing. I would just, come in here and add or take away by my multiplier. So whether that's 0.97 for 3% taken away, or 1.03 for adding 3%. And generally I would do pretty small increments. So kind of like timing, right? When you do timing, you really want to just do 1 or 2 degrees at a time, because it's one or 2 degrees, even 3 degrees can really do some damage if you're not careful. So it's just really about taking your time, taking some baby steps, just understanding what's going on, and just getting a feel for it, and not be too afraid about modifying or going that route. So what you've noticed is what I'm doing now is I'm not really using these interpolations. Just going by the multiplier by the percents, and then what I do the smoothing. I do use the smoothing. So if we go back over to our 3D chart, and let's just say this was a situation that happened after I tune, and I got a bunch of, let's say I just got some peaks and some valleys. So what I'll do is I'll put this in split mode here, and I'll focus in on that area. So I'll bring this over, and I'll say, okay, so about right there, so we're looking at 1600 RPM, around 1.14. So I'll just come in here and be like, hey, let's just smooth this out. So I'll go in this area, and I'll just smooth that entire selection. So the smoothing operation is what I use the most, but I try not to, there are times where I have to use interpolation, and I'm not saying, be afraid of using that. Just use the caution, because interpolation, what that's doing is it's filling in data gaps. So, let's say all this you have data for, and all this you have data for, and all this you have data for, but you don't have any data in this area. And when you're interpolating, it's filling in, it's saying, okay, what did you have here, and what did you have here, and then whether, depending on if you're doing the vertical interpolation or the horizontal, or if you're doing the entire selection, it's not raw, it's not real data in the sense that you collect it. It's trying to mathematically fill in those gaps. Sometimes that works, sometimes it doesn't, but where that becomes an issue is when you're in between fuel zones, and when you have some really big changes, like when I was showing the logs over there, where you had a little bit of rich conditioning and you take fuel away, a little bit of rich conditioning to take fuel away, and then you have a place in the middle here where you got to add a lot of fuel. You start to create these valleys and these peaks. So I apologize if I'm kind of rambling on here, but just really hope someone finds that helpful, because I'm telling you, you find a method for you that works, and just go with that. And I haven't seen a lot of YouTube videos out there, or just in general, just forums or anything where people talked about that. Generally the approach they take is just the old come in here, select everything, do your pay special by your percent or percent minus half, and then filling in with interpolation and all that. Whereas if you don't interpolate, you just say, hey, let's reduce that whole thing by 3%, or we add another 3%, and then we just go in there and smooth. I think you'll find out that it might work out a little bit better for you. So getting kind of lengthy here on that, but speed density is definitely a bigger beast out of the tuning processes. And, between math and timing, and even bigger than virtual torque isn't that difficult compared to. Speed. I'm not saying speed density is more difficult. It's just virtual torque doesn't take that much time compared to, speed density can be a rabbit hole where you just you can spend a lot of time just trying to get this dialed in. And it's pretty important to get these guys dialed in as close as you can to your commanded, because most likely when this speed density table is going to kick in for you is when you're at full throttle. And I prefer MAF the best because it's a more accurate representation of the airflow coming in versus trying to calculate it off of different coefficients like your MAP and barometric pressure and other conditions. But it also means it takes more time to tune it in and get it dialed in correctly. So, okay, guys, I'm going on pretty long here. Excuse me. And my throat's getting dry. So, I hope you got something out of that. Again, I'm not saying one way is bad versus another way. It's just keep it an open mind and try new things out. And I do think if you really understand what I was trying to get to there, that you might find it works out and might make your tuning process a little bit easier when it comes to speed density. So I think I covered everything. We covered the method of how it the driving conditions I go through to collect the data, how I get it prepped for speed density. Again, you're going to reset all those things except for your EQ ratios for power enrichment, which those shouldn't change anyways because you would have modified those in MAF. And we kind of went into a little bit of a strategy for how to tune speed density. So I'm going to leave it at that, and hopefully you guys found this useful for you. Again, if there's any questions or someone wants to discuss something further, feel free to leave it in the comments, and I'll try to help out. All right, so thank you. I'll see